Hello. Now, factors that affect the formation of these metallic bonds. Since I've told you previously that metallic bond is the electrostatic force of attraction between metals and the delocalized electrons, a number of factors affect its formation. First one is the number of protons. The higher the number of protons, the higher the stronger the strength the metallic bond. Take for example, the bond or the metallic bond you find in sodium solid is not going to be as strong as the metal bond formed by iron. The reason being because iron has more protons to contribute into the electrostatic force than sodium rather. Furthermore, or secondly, the number of delocalized electrons. The number of delocalized electrons an atom is willing to give out will warrant a stronger metallic bond compared to an atom that does not give out as much delocalized electrons. We will see that the metallic bond formed by the former is definitely going to be stronger than the ones formed by the latter. Finally, the size of the ion. The smaller the size of the ion, the stronger the bond. In this case, when an ion is formed by the metal atom, the smaller the atomic radii or other parameters used in measuring the size of metallic ion, the stronger the metallic bond. On that note, we have concluded the factors affecting the formation of metallic bonds. Let's briefly talk about properties of these metals as ascribed by the metallic bonds. Properties of metals. 1. Metals have high density because they are usually very strong force of attraction between the atoms. 2. They are usually malleable and ductile. Malleability of a metal simply refers to the ability for a metal to be beaten into sheets without breaking, whereas ductility is the ability of a substance, in this case metals, to be stretched into thin tins of wires. Furthermore, metals are good conductors of electricity. They conduct electricity through the use of the delocalized electrons, which are mobile. And that is why when they are introduced to an electric field, the current or the voltage is transferred through the metals by these mobile electrons throughout the entire length and breadth of the metal. 4. Metals have high melting and boiling points. This comes as no surprise. This comes as no surprise because of the strong electrostatic force of interaction between the positively charged atoms and the delocalized electrons. Furthermore, in this session, we are going to be talking about intermolecular bonding. Intermolecular bondings are those bonds that do not necessarily result or give birth to formation of new molecules, but help stabilize an already existing one. The two most popular intermolecular bondings are 1. Hydrogen bonding. This is a weak bond that is formed as a result of a dipole interaction between hydrogen and a strong electronegative element like oxygen and fluorine. This results to what we call dipole, partial positive and partial negative interaction among the bonds. And most times, compounds having hydrogen bonding tend to be bent in shape. Secondly, in these molecular bondings or intermolecular bonding is the van der Waals forces. The van der Waals forces are weak forces of interaction that make it possible for non-polar substances to form molecules like liquid and solids. They are weak forces of interaction, but they are very important in chemistry. We find van der Waals forces in iodine crystal lattice, where the atoms of iodine are held together by van der Waals forces. That concludes that for this session. In our next video session, as it is customary with us, we are going to be looking at relevant past questions from the UTME and SSCE examinations that pertains to these topics, and we are going to solve it.